All right, so use the given complex numbers z and w to find and simplify the following. So for number 1, if I have z equals 2 plus 3i and w equals 4i. Okay, so the first one, z plus w, well, that's literally just z, right? That's my z plus my w. There's my w. Add them together. So you get 2 plus 7i. Then you get z times w. Actually, I'll go in the order of the dots. So 1 over z. So 1 over z. Okay, so my z is 2 plus 3i. Okay, we can't divide by imaginary numbers, so we have to multiply by the conjugate. And that's what gets rid of it. So you're going to get 2 minus 3i over, now on the bottom, if I multiply this, all the i's will cancel out. So 2 times 2 is 4. 2 times negative 3 is minus 6i. Positive 6i, see, those cancel out. And then minus 9i squared. I squared is negative 1. So negative 9 times negative 1 is plus 9. So that's 2 minus 3i over. So 4 plus 9 is 13. Now, we want to write it in the form a plus bi. So we just need to break up that fraction. So you're going to get 2 over 13 minus 3 over 13i. The next one is z bar. So then z times w. So z times w. So distribute, that's 8i, and then 4, 3, so that's 12, so plus 12i squared. I squared is negative 1, so that's negative 12 plus 8i. Z over w. So z over w. So you need to multiply by the conjugate. So and then minus 12i squared. Over, and then that's minus 16i squared. So I squared is negative 1. So negative 12 times negative 1 is positive 12 minus 8i, and that's going to be over negative 1 times positive negative 1 is positive 16. So that's 12 over 16 minus 8i over 16. So that's 3/4 minus 1/2 I. So z squared. So z is 2 plus 3i, so squared. That's the same as 2 plus 3i times 2 plus 3i. So that's 4 plus, that's 6i and 6i, that's 12i, and then plus 9i squared. So that's negative 1. 9 times negative 1 is negative 9. So that's negative 5 plus 12i. And then w over z. So that's w over z. Again, you have to multiply by the conjugate. And then make sure that you write into the a plus bi form.